In today's class, we can discuss what is prime factorization, what are the ways of doing prime factorization. We can detail all this matter with the help of examples. Here, the number 36, I have written its factors. What are the factors? 1 into 36, 2 into 18, 3 into 12, 4 into 9, 6 into 6. Now this reverse order also. That means 36 into 1, 18 into 2, 12 into 3, 9 into 4. So these are the factors of 36. That means we are expressing 36 as a product of two numbers. This is known as factorization. What it is? Factorization. That means I am factorizing 36 as 1 into 36. That is a factorization. 2 into 18. That is also a factorization. 3 into 12. So, what does it differ from prime factorization? This is factorization, isn't it? So, what will be prime factorization? When you notice the factors. Here what are the factors? 1 and 36. What is the case of 1? Is it a prime or composite? 1 is neither prime nor composite. So we cannot say it is a prime or composite. What about 36? Is it a prime or composite? It is a composite, not prime. So this we cannot say this is a prime factorization. Next case, 2 into 18. When we look for these two numbers, what type of number is 2? Yes, 2 is a prime number. But what about 18? Whether 18 is a prime number? No, 18 is composite. So here also we can say this is not a prime factorization. Now this is a third case. Here 3 is a prime but 12 is not prime. It's a composite. So this is also not a prime factorization. Now here 4 and 9 both are composite. So this is also not prime factorization. Then what? 6 into 6? Also a composite number. So what is prime factorization? That means when all the factors are prime numbers. So here we have to convert these composite numbers into prime numbers. Then if all the factors are prime, then we can say we are writing in prime factorization. Now how can we convert here? For that, I took any two factors. You can take any two factors, okay? Here I took what? 2 into 18. Here 2 is already a prime number. So which I need to convert? This 18, isn't it? 18 is a composite number. So I need to convert. So I go for the factors of 18. So I converted 18 in equal to 9 into 2. Whether my step is over? No. Why? This 9 is not prime. What is this 9? It's again a composite. So we need to change this 9 in this step, isn't it? So how can I write 9? This 9 I can again factorize into 3 into 3. Now I factorized all the composite numbers. So instead of 18 I can write 9 into 2 and instead of that 9 I can write 3 into 3. So I factorized 36 as what? 2. This 2 you can write same. Then 3 into 3 instead 9. Then this 2 that is a prime here. So I wrote one prime factorization. Now check whether the prime factorization is correct. What is 2 into 3? 6. 6 into 3? 18. 18 into 2? 36. So here you can find any composite number here in this factorization. No, 2 and 3 are prime. That means we converted 36 as prime, as a product of prime numbers only. This is known as prime factorization. Expressing a number as a product of its prime factors. That is prime factorization. Now, this prime factorization we can perform in two different ways. One is factor tree and the other is long division method. We can look through examples. See here, I said for factorizing we can take any two pairs, isn't it? Here I am factorizing in another method. Here the number to be factorized is what? 36. So I took two factors of 36. What are they? 9 and 4. In the earlier case I took 2 into 18. Now I took 9 and 4. Whether this 9 and 4 are prime? No. So again we have to factorize. So this 9 we are factorizing as 3 into 3. And 4 we are factorizing as 2 into 2. Now again we need to factorize? No. Why? Because in the last step we got all the numbers as prime. So the prime factorization of 36 is 3 into 3 into 2 into 2. Earlier we got one factorization. What was that? Earlier we got 36 equal to 2 into 3 into 3 into 2. Now what we got? 3 into 3 into 2 into 2. Are they same? Yes or no? Yes, they are same. Just check. Here we have 1 3. Here also we have 1 3. Here also. Here 1 2. Here 1 2. Here also. But here I took the factors which are 18 and 2. Here I took 9 and 4. What you can understand from this? Whatever factors you take, whichever factors you take, the final prime factorization will be same for the same number. 36 will have the prime factorization what? 2 into 3 into 3 into 2. This will be the prime factorization of 36. No other number you will get. Now, factorizing in this way, like branches of a tree, are known as factor tree, isn't it? We are expressing this prime factorization as first you express this 36 as what? Two branches. Which are the first two branches? 9 and 4. So, the product of 9 and 4 gives you 36. Now, again you simplifying this 9 factorizing. So, 9 again what? 3 into 3. Again 4. So, in this method you have to, the final step, all the numbers should be prime. Then that number is prime factorized. And this method that I am writing in this method is known as factor tree. So, if the question is prime factories using factor tree, you have to do in this method. Now we can look what is long division method. Long division method means it's a type of division itself. See, factorizing 60. This is long division method. How? The number is 60, isn't it? We have to prime factorize. So, the very important thing is that the number we are using here, isn't it? That should be prime numbers. So, first we are prime factoring 60. So, we have to divide that number. We need prime factors. So, 60 is an even number. Here we are using the divisibility rules. If you're getting a larger number, here we are using the divisibility rules. 60. Since it is an even number, we can start with which prime number? 2. So, I am dividing 2 with 60. You will get 2. 6 in 2 how many times? 3. Then writing the 0, Z. So, 60 divided by 2, you are getting 30. Now, again 30 is an even number. You can use 2. Again dividing 30 with 2, you are getting 50. See, if you don't know the division like this, you can divide in the working column by the normal division. Once you become more practice, you can do in this way. So, they divide 30 in the working column with 2. Then you will get quotient. You are writing the quotient, not remainder. What is the quotient you are getting? That you are writing here. What is the quotient? 15. Now, is 15 a prime number? A even number? No, it's an odd number. So, we cannot use what? 2. Now, the next option. Either we can use 5 or 3. So going from the small, I am using 3. So 3 into what is 15? 5. Now 5 is a prime number. So again we can use a 5 itself. So 5 in 5, 1. Now you got last what? 1. So you can stop your prime factorization. Now make sure once more that the numbers you used here are prime. 2 is a prime number. 3 is a prime number. 5 is also a prime number. So all the numbers we used here are prime numbers. Now one more last step. Confirm the answer is correct. What is 2 into 2? 4. 4 into 3? 12. 12 into 5? 60. So our factorization is correct. Also all the numbers are prime. So the prime factorization of 60 is 2 into 2 into 3 into 5. So this is long division method and the other one is factor tree. Now first example. Write the greatest 4-digit number and prime factorize it. Here they didn't specify which method, use factor tree or long division method. But since it is the number greatest 4-digit number, means you know it is a larger number. So you don't know the multiplication table of that 4-digit number. So here you can, in these cases and all, you can use long division method. So what is the greatest 4-digit number? We need to prime factorize that number. So the largest 4-digit number is what? 9999. We need a prime factorization. So here what? All numbers are 9, isn't it? So it is divisible by 3. Or you check the divisibility by 3. 9 plus 9, 18. 18 plus 9, 27. 27 plus 9, 36. 36 again adding 3 plus 6, 9. Is it divisible by 3? Yes. So 3 you can, it is divisible. So dividing with 3. 3 in 9 3 times. Again 3 times. 3, 3. Again 4 3s you are getting. Again this is 3 is a divisible. So dividing with 3 you are getting 1, 1, 1, 1. Now how will you check the divisibility of this number? This is not an even number. So it's not divisible by 2. When adding 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. The sum is not multiple of 3. So not divisible by 3. Next, divisibility by 4. The last 2 digit 11. Is it divisible by 4? No. If it is an odd number, none of the even numbers, it will be divisible. So no need of looking for any even numbers. Now 5. But what we will look? The ones place. Here what is in the ones place? Then 6. 6 will also be not divisible. Then 8 also. 9 we said sum. 10. Then what is remaining? 11. So checking the divisibility by 11. I said we are subtracting the alternate digits. So 1 here, 1. What is 1 minus 1? 1 plus 1, 2. This 1 plus 1, 2. 2 minus 2, 0. So what is the divisibility rule? It is divisible by 11. So we don't know 11 into what is this number. So in that case you can divide and check. You know 11 is a factor, you know. So you can divide and check. Then you will get 11 into 101 is this number. So you got here 101. Now 101 again you are checking 1 plus 1, 2. This is not an even number, not divisible by 2. 1 plus 1, 2. 3 will not be a divisible. Again this is an odd number. But if you check that, you can see this 101 is a prime number. Prime number means what? Only the factor will be that number. It's and 1. So you prime factorize all the terms. So what you are getting? 3 into 11 into 101. So what is the prime factorization of 9999? 3 into 11 into 101. Make sure that all the factors are prime. Here all the numbers are prime and multiply and verify your answer.